So as we read the instructions, it says, tessellate the region under the parabola and above the x-axis to find the lower estimate and the upper estimate for the area under the graph. So the graph that's on the back of your paper or the front of your paper is the graph y equals 4 minus x squared divided by 4. All right, then we're going to find the relative difference between our two estimates. I know you guys are freaking out right now. So what we're going to do is look at step number 2. We're going to find the area under this, Bryce. I'm not going to deal with it today. I need us to pay attention. You guys are consistently the lowest scoring class that I have. So something has to change. Point made? Let's move on. So we're going to find the area under this parabola by using blocks that are 1 length long. So that would be like this block right here. Does that block fit above the x-axis and under the curve? So you would shade that block in on your paper. Shade it in. Alright? Now, I look at my next block. Does this block fit perfectly, all of it, under the parabola?
No.
Nope. Does that one?
Yes.
Yes. Shade it in. What about this one? Yep, shade it in. This guy? I'm going to go ahead and say that's a yes. That parabola is right on the intersection of those 2 points, so I'm going to go ahead and say that it's under the curve. What about here? No. Here? Yep. 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 So that's all in quadrant 2. Now we got to go to quadrant 1 and do the same thing. Do you think there's going to be any similarities there?
Yes.
It's going to be the same thing, just reflected across the y-axis. So that generates our lower estimate. Why is it called a lower estimate? Because it's under the parabola. So we have to figure out what is the area of all that black region. 14 squares. So the area for this is 14 units squared. Is it as bad as you thought it was going to be? Guys, we're coloring boxes today, right? Yes, sir. Does it matter what? I generally start at the top of the parabola and work my way down because you get this thing called the waterfall effect. I just work left to right. I just work left to right. How do you want to? Let's do the next one. Let's do it with your flavor. How do you want to do it? Where would you start, Bryce? We're doing an upper estimate now, so any box that the parabola is contained in has to be covered.
What? That's like the same thing.
Like right here?
Yeah.
So is the parabola in that box?
No. Oh.
Yeah.
Oh, so if it touches the box, then yes.
So I have to, I have to cover that up. Right now I'm trying to do an overestimate. I'm trying to put boxes over the curve.
Oh.
So that one's good. And then what would you do? Where are you gonna? So this is called the waterfall effect. If this box is covered, every box beneath it should be covered. The waterfall effect. So I'm gonna go ahead and do that. All right, would you go left or right now? You're gonna go right and do the same thing. So justifying is that square covering the parabola, and then waterfall effect. So on the upper estimate, the box has to cover the parabola. On the lower estimate, the box cannot go outside the parabola.
Oh.
Alright, so on the lower estimate, our box cannot leave the parabola. That's the barrier there.
Yeah.
But on the upper estimate, we have to cover the parabola up.
So couldn't you just color in all the boxes that that line is touching?
Yeah, so
So why don't you just go around?
is that?
Yep.
Yes. Waterfall effect. So I can mirror that on the other side. Now what? So do I cover this one up?
Yes.
Yep.
What would you do if it like intersects right between like traffic on one?
This one?
Yes.
So because it's on the actual intersection, the corner of the box covers it. That's where it gets kind of weird, right? Like this intersection, this box is covering that corner, and I don't know, does that make sense? Okay. So then you have to count how many boxes you have there. 26 boxes?
Yeah.
So the only reason I screwed this up earlier is I couldn't count correctly. So this is 26 units squared. So we have a lower estimate of 14 units.
So this is lower.
We have an upper estimate of 26 units. So we have to find a relative difference based on the upper estimate. So here's your first proportion that will start for the rest of the unit 9. So what is the difference between those two estimates? 12. And what is the upper estimate? So we'll use that to generate a percentage. 12 divided by 26. So the relative estimate difference is 46%. So that means that we have a 46% error. Does that make any sense to you guys? 46% error? Alright, no?
I don't get. I mean, I'm not doing.
You don't get
I don't get like what.
Go ahead. Ask it.
I really don't know how to ask it. I know how to get like different kinds of percents. I don't know. It's just, that's just your answer.
Like this number doesn't really mean anything to you. If you know how to generate it, it doesn't
Yeah.
mean anything to you.
Yeah.
So I'm gonna guess your bank account with a 46% error. Okay? Here's a 46% error of me guessing your bank account. It could be anywhere from $4 to $96. So you could have 50 bucks in your account, and I could guess as low as 4 and as high as 96 and technically be correct. Does that make sense? So I could be 46 high or I could be 46 low, but I'm still right. So is that an accurate estimate? Not really. Not really. So the real area could be 4 under the curve, the real area could be 96 under the curve, anywhere in that like 92% window, upper or lower, I'm technically correct. So good estimate or bad estimate? Pretty terrible estimate. So what I can do is I can manipulate my squares. It says now tessellate the squares by using a side length of 1/2. So when I do this, instead of using one full square, I'm going to use side lengths of 1/2 by 1/2. So when I did this on my paper, I went ahead and I took my pencil and I cut all the boxes in half. So I cut them in half going this way. This is going to be the second set of graphs. And I cut my boxes in half going this way. Look at all those boxes. So do you think my estimate's going to be more accurate?
Yeah.
Probably. So let me show you how I do this, right? I'm not going to worry about the waterfall effect. What I'm going to do is I'm just going to place boxes for my lower estimate. The box has to be completely contained under the parabola. If it goes outside the parabola at all, it doesn't work. So I'm just going to work on the parabola. Is this completely under the parabola?
Yep.
Yes. Okay. Sticking near the parabola. Is this one completely under the parabola? That was one. Well, you were asking about that one, right? So it's right there on it. Is it under it? I'm going to say yes because it's kind of right there on the intersection. Okay. What about this one? Is it completely under? No. No. So I'm going to move over. What about this one? Completely under? No. This guy is, though.
What if our lines aren't really accurate enough for that? Or do we have to like use a ruler?
Not really. I mean, it's just kind of like you're looking at the corner boxes. So when I did this, I just drew plus signs over the parabola. I didn't do all the boxes. So it's really just kind of like, I know it's not perfect on your paper, but just kind of understanding the technique a little bit. What about this guy right here? Yeah. This guy? No. This guy? I would say yes. This guy? So it has to be this guy. So now they're going to waterfall down all these boxes. And I'm just going to take my black pencil and shade everything down. Now I should get a perfect reflection across the x-axis on the other side, across the y-axis on the other side. So help you. You've already done the work. Just make sure it looks correct. How does that look? It looks a lot more full, doesn't it? So now we have to take the inevitable task of counting all those boxes. Now, remember that a box is quantified as 1 square unit.
Wait, can you just like count how many boxes we're actually like in it divide by 4?
So what I'm doing here is following the x and y axis. It's really hard because I've covered up all my lines here. Cool.
At the top and the bottom.
So 1 is right here. I don't know how to do this. Actually,
Can you use that line thing?
this one?
Yeah.
Right here. So I'm just gonna count this side, and I'm gonna double my estimate. Does that make sense? Because they should be perfect. So 1, 2, 3, 4, 5, 6, 7.
Like your sides of the parabola aren't,
Symmetrical?
yeah,
Where did I screw it up?
right above 6 on the left side, it's not there on the right side.
Oh, right here?
Yeah.
Good call. Okay, so I got 1, 2, 3, 4, 5, 6, 7.
There should be 7 there, right?
So I can call this 8, right? Add those two halves together to make one whole. So we'll say 8. And then 3/4 and 1/4 is 9. And then 2 boxes would be half. We good with that?
Where you see 2 boxes.
Oh, sorry. I have 1 box right here. So is that 9 1/4?
1/4.
9 1/4. So what is 9 1/4 times 2?
18.5.
So my lower estimate should be 18.5 units squared. Whew. So now we'll try the same thing with an upper estimate, an over estimate. Now I'm not going to use the boxes here because let's see if we can just kind of sort it out together. I'm just going to do my plus signs in each of these boxes. Does that already look simpler? Yeah? So, does this box go outside the parabola? Shaded down. Is this box, or do I need this box? Does this box go outside the parabola? What about the one above it? Okay. Is this box covering the parabola? This box? So as we count these, I'm going to count full boxes first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now what? 10.5 plus another 1.5. So it's 10.5 plus 1.5. 10.5 plus 12. So if this side's 12, how big is this side? So the total area over the curve would be 24 units squared. Right? Our upper estimate is 24 units squared. What was our lower estimate? What was it? 18.5? So the difference between those two estimates, 24 and 18.5. The difference between 18.5 and 24. 5.5. 5.5.
So what would you put, 18.5 over 24?
5.5 is the difference over the upper estimate, which is 24, which means our relative difference would be, as a percentage, 23%. So when we did boxes by 1 full unit, we got 46%. Then when we cut the boxes in half, we got 23%. Wait a second.
It's less fair.
It's
It's more accurate.
exactly 1/2. Does that make sense to you? We cut the boxes in half, and our estimate got cut in half. What if we cut it in tenths? No, dear God, no.
You filled the box.
Do the math.
So what this is approaching you is like here you can take the limit of, right? And it gets really weird. You start getting the limits. This is a pre-calc concept. We'll do one last one. Now we're gonna cut each square in half, but as a triangle. So we're gonna cut each square in half, but as a
Oh,
triangle.
like just diagonal.
Exactly diagonal. So I'm gonna cut each box that contains a parabola in half. And I'm gonna estimate it.
Wait, are they going the same direction on both sides?
So on this side, I'm gonna have to cut it going the other way. Does this hurt your little peanut? So is this triangle completely under the curve?
Oh, yeah.
Why do you have to do it opposite?
Because I don't want to cut them like this. It wouldn't really work with it. So this triangle is completely under the curve. Is this triangle completely under the curve? No. Is this one? I'm going to go ahead and say yes, this one is. Is this one completely under the curve? No. This one? No. It is? This triangle is completely under the curve? That's not going to work. So what I'm going to get is a shape.
A little triangle. That one. Yeah.
Well, I mean,
You forgot the triangles on -1 and positive.
is that triangle completely under the curve?
Yes.
And this one?
Yes.
I don't know. That one's weirding me out for some reason. I have this. See this little bit of white space right here? So I didn't count that one. That's what I have on my paper. I didn't count this box because there's a little bit of white space showing. So I didn't count it as completely in there. So I got 1, 2, 3, 4, 5, 6, 7, 8 and a half. I got 8 and a half. 8 and a half times 2 is 17. Yeah, split.
It's almost a pyramid.
Almost, yeah, it's almost kind of, it's a weird shape. So then the upper estimate, this box would cover it up, wouldn't it? You need this triangle to cover it up. But would this triangle cover up the parabola?
Oh, wait.
This one would. Would this triangle cover up the parabola? Yes. Would this triangle cover up the parabola? Then you need this whole box to cover up the parabola. We're trying to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. Which would be 23. So our upper estimate is 23. Our lower estimate, 17. The relative difference between those, 6. And 6 over 23. 26% difference. Does that like?
And then you color everything else in.
Yeah. So you should have this like, I don't know, what is that, pentagon looking shape? So, a lot of weird stuff, right? A different way to think. Aren't you glad that wasn't on your test?
Yes.
So that was supposed to be homework, all of it. I was just supposed to teach it to you in a different way and then give that to you for homework. Huh?
You don't have homework?
So no, that is the homework. Look, it's a hard concept to teach because it is pre-calculus.